Hello, everyone. I am Professor Marcos Santos, and I coordinate the activities of the Operational Research House. And today, we are going to learn how to use ELECTRE-MOr web system to apply the ELECTRE-MOr method. Hello, Professor. How's it going?
Hi, Professor. I'm fine. How about you?
Oh, fine. Thanks. Today, my guest is Professor Igor Pinheiro, intermediate officer of the Brazilian Navy, graduated in Naval Science at Navy Academy in Rio de Janeiro in 2014, with specialization in the area of machinery and post-graduation in naval propulsion. He is a Master of Science in Industrial Engineer with emphasis on operational research from the Federal Fluminense University. He is a reviewer for the journal IEEE, the Latin American Transactions, International Journal of the Analytic Hierarchy Process, Journal of Computer Science Research, the Open Public Health Journal and Bulletin of Electrical Engineer and Informatics. Member of the Operational Research UK Society and visiting professor in public and private institutions in disciplines of operational research, multicriteria, decision-making, and decision support systems. So, Professor, thank you so much to accept my invitation to talk about ELECTRE-MOr method and the software where we can calculate the results from the method. Well, make yourself at home. Let's get started.
Thank you, Professor. Hello, everyone. My name is Igor Pinheiro. I'm a Master of Science in Production Engineering with emphasis on operational research. It's a pleasure to participate in the Operational Research House. I thank this honorable invitation made by Professor Dr. Marcos dos Santos to talk about the ELECTRE-MOr method and the web software that implements this methodology with the goal to disseminate and spread this new multi-criteria hybrid method around the world and helping decision makers to make better decisions. So I will share my presentation. Professor, could you see my screen?
Oh, yeah.
Okay, thank you. So I'll present ELECTRE-MOr web software tutorial, learn by getting your hands on. I hope you learn how to use this multi-criteria method, making practical exercise, putting your hands on. So, in this presentation, I'll follow these topics: introduction, problems typology, background, practical example. I'll present one real application of the ELECTRE-MOr web software. I'll present some applications possibilities, and finally, the reference that based our presentation. Introduction: multi-criteria decision-making methods are techniques for advising the decision-making agent that can be individual, a group of individuals, an expert committee or leaders for making decisions on complex problems. I highlight this term, complex, because in many cases we have conflicting criteria with typical trade-offs. These methods aim to evaluate, order, select, or classify alternatives through different points of view. I highlight this point. This contributes to complex scenarios because you have to aggregate different opinions, different considerations, and points of view expressed by many decision makers.
I know, because it's so hard to find a balance between two criteria, for example, cost and comfortable. For example, if I want to buy a car, and I would like the car is comfortable and cheap. So there is a conflict in this criteria. So if I want a more comfortable car, I need to pay more for that, I think. So sometimes it's so hard to find, how can I say, balance between two criteria that they are different and there is a conflict between them.
Exactly, Professor. So. In this context, in complex scenarios, like I said previously, the multicriteria methods present a good adherence to this kind of problems because they provide structuring and understanding.
Exactly.
Way to
give us a structure to the good decisions, better decisions.
Yeah, and as a result, these methods provide better decisions with a reliable, transparent, and robust scenario to understand and considering different opinions in the decision-making process. Talking a little about problems typology in multi-criteria context, we have some axiomatic models. In the ranking problems, we seek a growing or decreasing ordering of the alternatives, first, second, third. In selection problems, I seek the best alternative to achieve a certain goal. And in sorting problems, that is the main subject of our presentation, we seek distribute the alternatives into predefined classes. So, for example, if I have class A and class B, alternatives A8 and A7 are, in this case, distributed in class A because they present the best performance among the alternatives analyzed in the light of the predefined criteria. In this case, in this kind of methods, I can't define which one of these alternatives is the best. So if I have to decide between A7 or A8, I have to use another method in a hybrid methodology. So in sorting problems, I distribute these alternatives in classes, and all these alternatives in each class present the same performance in the light of this criteria. This is the context of ELECTRE-MOr method. Background. Firstly, I want to present the fourth paper that proposed and presented ELECTRE-MOr to academia and society. The paper entitled Choosing Flying Hospitals in the Fight Against COVID-19 Pandemic, Structuring and Modeling a Complex Problem Using the VFT and ELECTRE-MOr Methods. Paper published in the journal IEEE Latin America Transactions, indexed in Journal Citation Reports and Scopus databases, which illustrate the relevance of the journal. And to illustrate a possible application of the method, we applied the ELECTRE-MOr methods to classify 6 aircrafts in Brazilian context against the pandemic. And we can see 2 procedures to obtain the class limits, BH and BN. So ELECTRE-MOr provides two classifications in the pessimist scenario and more two classifications in optimist scenarios, providing in all four distributions, which allow us verify the behavior of the alternatives into several scenarios, and it provides additional information to the decision-making process. In this specific case, we can verify that Legacy 450 and Pareto 500 present performance class A in all analyzed scenarios. So in this case, these two aircrafts can be considered as the most indicated. As an advantage, I could choose, for example, the more ship between these alternatives. So when I analyze,
and I think the method ELECTRE-MOr was born at that moment, right?
Yes.
It was published in IEEE, right?
Yes. This was the first paper that applied and showed ELECTRE-MOr to academia and society. It was published in 2020, the final of the year, in the pandemic context here in Brazil.
This information is so important because if somebody wants to use the method in papers, thesis, or whatever they want, he needs a foundation theoretical to use the method. So it's important to know that this paper is the first paper that ELECTRE-MOr was used. Like,
exactly, Professor.
Like the method was born at that time. Yeah. Okay.
So
go ahead.
One limitation of the previous paper was the language. The paper was written in Portuguese, and it dificulted the dissemination and the spread of the method around the world. So in September 2021, 3 months ago, we published this paper, Strategic Study for Managing the Portfolio of IT Courses offered by a corporate training company, an approach in the light of ELECTRE-MOr Multicriteria hybrid method, published in International Journal of Information Technology and Decision-Making, also indexed in JCR and Scopus databases. And in this paper, we analyzed a case study, a real case study, classifying, distributing 18 alternatives in 3 predefined classes. Class A, the courses that would be prioritized by the management of
is this paper writing in English, the second paper?
In English. All in English. This paper is right in English. It facilitated us to show the method around the world.
So then the first was writing in Portuguese. The paper published in IEEE was writing in Portuguese.
Yes.
But this is the first paper that I can say the method was showed. And the second paper is about the strategy study for managing or for portfolio of IT. Okay, this is the second paper, all whole in English.
Yes.
Okay.
And in this paper, we also provided more detailed information about pH, BN. We provided diagrams and schematics to show how the procedures
More data.
work.
We have more
Yeah.
data to analyze.
Yeah,
Okay.
to facilitate the students or the researchers to understand the method and
Okay. I
use
got
it in. So in this application, we have 18 alternatives distributed in 3 classes. Class A, courses that should be prioritized by the management of the enterprise. Class B, course that should be maintained. And Class C, the course that don't have return to the enterprise. Therefore, they should be discarded by the portfolio of IT courses. This enterprise wanted to restructure this portfolio and decide how, which are the most dedicated courses to be maintained or prioritized. So this was our goal in this paper. To illustrate the application of the method, let's take a sample. So a magazine decides to get a classification of 6 scores based on the preference of 2 experts. Here, I highlight one important feature of the method. This allows the opinion of more than one decision maker and aggregate their preference, considering their opinion in the final result. So it's an advantage sociological of our method. In this case study, we analyzed 3 criteria: price, car trunk, that is the internal space inside the car to carry things, and design. Please note that these criteria have different natures. Price is a numerical criterion, and I want to minimize these values. So I seek the minimum possible value in this criterion. Car trunk is also a numerical criterion, but I want a maximum space. Design, in turn, is a qualitative criterion and depends on the perception, the opinion of the decision makers. So it's so hard to define a cardinal value or a numerical value to this kind of criterion. So in this case, ELECTRE-MOr provides a pairwise comparison between the alternatives in the light of this criterion to obtain the cardinal values and facilitating the visualization of the problem. The decision makers analyzed 6 alternatives: Ford Focus, Volkswagen Virtus, Toyota Corolla, Nissan Sentra, Honda Civic, Kia Cerato, distributing these alternatives into predefined classes, 3 classes in this case: Class A, the best cars; Class B, intermediate cars; Class C, the worst cars, as we will see in the next slides. A general overview of the problem: 2 experts analyzing 6 alternatives in the light of 3 criteria in order to classify alternatives into 3 predefined classes, A, B, and C. So let's take the steps of the method. The first step is evaluating the criteria between them through a pairwise comparison. And in order to facilitate the visualization, we have this comparison matrix: price per trunk design, price per trunk design. This relationship means price is equivalent to price. It's logical because I'm comparing one criterion with itself. So all the relationships in the main diagonal are equivalent. And to establish this preference, ELECTRE-MOr use this table. So it's a 5-point scale that varies from -2 to 2. Equivalent is equal to 0, worse -1, much worse -2, better 1, much better 2. The symmetrical values, the reciprocal values, are inverse. So if price is better than car trunk, so car trunk is worse than price. So we have these inverse relationships. The next step is to transform the original preferences into cardinal values, as we can see in this table. Equivalent is equal to 0, much worse is equal to -2, for example. So we sum each line, obtaining the score, and in order to standardize the values, we've applied this equation, the value minus the minimum divided by the maximum minus the minimum. This normalization aims to make all the values with the same scale in order to be compared and provide a reliable result. One question: is it possible criterion with 0 weight? No. If a criterion presents 0 weight in multi-criteria decision making, it has to be excluded by our analysis because it doesn't interfere in the final result. So in our modeling, a criterion with 0 weight assumes 1% of the subsequent minor. In this case, 1% of 0.8 is 0.008. Analogically, analyzing the preferences expressed by decision maker 2, they follow the same steps, establishing the ordinal preferences, transforming this preference in cardinal values, obtaining the sum of each line, normalizing the results. The 0 value assumes 1% of subsequent minor. In this case, 0.002. Then we have to aggregate this preference. It's simple. We sum each line to obtain the final weights of the criteria. In this case, the criterion price has 1.8 of weight, car trunk 0.01, and design 1.2. Then we have to analyze the alternatives in the light of the qualitative criteria, following the same process presented previously. So the decision maker 1 decided based on the same table of 5 points, his preference in order to transform the ordinal values into cardinal values. So in this comparison matrix, we have the alternatives, compare it pair by pair. So focus in criterion design was considered worse than virtues by the decision maker 1. And he makes these comparisons for all these alternatives. I put this green background in order to show that in the ELECTRE-MOr software, only these green comparisons are necessary because the symmetric values are automatically filled by the software. It decreases remarkably the cognitive effort for the decision makers. The next step is transform this ordinal preference into cardinal values. The same process is made by decision maker 2. And we made the aggregation of these alternatives, summing each line, obtaining the performance of these alternatives in the light of the qualitative criterion design. So in this case, we have all the criteria with cardinal values in order to input in the software. I highlight that the software allows us to make these pairwise comparisons, analyzing the qualitative data in order to transform them into cardinal values. Now, talking a little about the BH and BN procedures that serve to obtain the class limits that will be compared with the alternatives in order to distribute these alternatives into predefined classes. ELECTRE-MOr provides 2 ways of obtaining these limits. And to illustrate, first of all, analyzing the BH procedure for 3 classes, I chosen the criterion cartridge, and to obtain the lower class limits for BH procedure, we have to calculate the H value. It's equal to maximum and minimum divided by the number of classes. In this case, the maximum is 340, the minimum 300. Maximum and the minimum divided by number of classes 3, I obtain 13.33 as the value of H. Then I have to sum this H value to the minimum value of each criterion. So I obtain for BH1 313.33 and BH2 326.66. I highlight that for n classes, I have to obtain n-1 profiles, because if I have BH2, BH1, and minimum, for example, let's forget all these values below the minimum. So if I have values above BH2 and below the maximum, I have the class A. Values between BH2 and BH1, class B. Values between the minimum and BH1, class C. So the BH procedure divides the interval between the maximum and minimum into equal parts. The BN procedure. The BN procedure establishes profiles for each criterion so that each subclass has the same number K of alternatives, where K is the number of alternatives divided by the number of classes. In other words, BN procedure establishes quantiles, typical in statistics, putting equal number of alternatives into each subclass. So in this case, we obtain the value of K, and this value is the index of the alternative, and this alternative is equal to the class limits. Let's analyze the example, and I think it will be clear. So BN2, in this case, is the kth best alternative score. K is equal to 2. So BN2 assumes the second best score in this criterion. In this case, 330. BN1 assumes the 2 multiplied by k, and this value is the index of the subsequent limit. In this case, 2 multiplied by 2 is equal to 4. So I want the fourth best score. In this case, 315. With these two procedures to obtain the class limits, we obtain the performance matrix. So I have 3 criteria: price, cache rank, design. These values were obtained by pairwise comparisons, as seen in previous slides. Price is a cost criterion, so I seek the minimum value. Therefore, I highlight this point: BA2, BA1, BN2, BN1. In criterion design and cache rank, observe that BA2 is greater than BH1. That is, the greater the class limit, the greater this model, this absolute value of the performance. For the criterion price, as I want to minimize it, it's the inverse. So the best performance, that is BA2, is less than BH1, because I want to minimize these values. When applying the software, it will be clear. The software multiplies the cost criteria by -1 in order to make more clear this difference between minimize and maximize criteria. Any doubt, Professor? Is it clear?
No. Okay.
Can I proceed? Okay.
Got it.
Q, P, and V. These are preference thresholds. So Q is the indifference threshold. So a difference between two alternatives equal or less than this value of Q represents an equality, or indifference between two alternatives. A difference between Q and P represents a weak preference in favor of the performance of the alternative with best performance. A difference greater than P represents a strict preference in favor of the alternative with the best performance. V, or zero, is the discordance threshold. And it's important to analyze a general overview of the criteria, because if one alternative outranks or is better than another one in all criteria, except in one criteria, and this alternative is outranked or is worse than this other alternative with a difference greater than V, this first alternative doesn't outranks or can't be considered better than the another one. So it's the concept of zero. So I propose that until now, we showed the software. I'll let this slide for some seconds in order to the audience scan the QR code or access the website.
I wanna use the software. I scan this QR code to open the software.
Yes. And the software allows us to use the methods by mobile phone, laptops, and
is it open for everyone?
Yes,
So
everybody
can use the software.
Everybody can use. It's an open access software. And
it's
it's
wonderful.
necessary only input the data, and the software provides the results of the method, dividing the
don't need-
alternatives into predefined classes.
Okay,
You don't need install softwares or
or to make
this kind of
the
things.
download.
No,
No.
no.
Okay, wonderful.
So let's see the software. If you want, search in Google, ELECTRE-MOr.com. It's the first result.
The first one
So
in Google, on Google. Okay. So at this time, explain step by step for everyone understand how to use the software.
yes, in my opinion, this is the most important part
Exactly.
of our presentation.
I think so.
So let's go. To facilitate the input of data, I prepared a spreadsheet in Excel to facilitate the visualization of data and input in the software. I'll make this process very slowly in order to facilitate to the audience use the software. So the project setup, set the project name, in our case, project car, a little description, project.
And explain about the problem. Okay.
Yeah, it's personal.
Decision problem.
Number of classes, in our case, 3. Number of criteria, price, car rank, and design, 3 criteria. Decision makers, 2 decision makers. Number of alternatives, 6 alternatives. Cutoff level, lambda, is the minimum value of credibility to agree with outranked relationship between 2 alternatives. So in this case, I will show 0.7, but this value can be changed after the results in order to verify the behavior of the alternatives in our analysis. Continue. Here we can register decision makers, criteria, and alternatives. So I will choose decision maker 1 and 2 as the decision makers. Criteria, price, car rank, and design. And here I have to choose the type of criteria. So price is a numerical criterion. And I seek decrease this value, minimize this value. Car rank is a numerical criterion, and I want to increase this value, maximize this value. Design is a qualitative criteria. Note that when I choose qualitative criteria, I don't have the option to choose between increase or decrease, because in qualitative analysis, the decision makers naturally choose the best option for taking into account its own opinion. Alternatives, Focus, Virtus, Corolla, Sentra, Civic, Cerato. I'll wait some seconds in order to you type these alternatives if you want. Can I continue, Professor?
Oh, no, it's okay. I got it.
Okay. Continue. The next step is to input the numerical value. So price of the focus, 90. I highlight that these values are arbitrary. Our intention in this presentation is to present the software. So these values are not real, so are arbitrary, are illustrated. Car trunk focus 300, Virtus 95, car trunk 320, Corolla 120, car trunk 330, Sentra 100, and 310. Civic 115, 315. Cerato 98, 340. So I input all the numerical values. Continue. The next step is to establish the pairwise comparisons between the criteria. So in order to facilitate, I put the comparison matrix here. So price compared with car trunk. Price is more important than car trunk for the decision maker one. Decision maker one, price is more important. In this step, it's important to highlight this point, to emphasize this point. We have to slide the bar towards the best alternative. So if I slide to left side, I'm considering price is more important than car trunk. If I slide more for left, price is much more important than car trunk. If I slide to right, price is less important than car trunk, or price is much less important than car trunk. So in this case, price for decision maker one is more important than car trunk. So to left. Price is equivalent to design, so I put the bar in the middle. It's equivalent to as important as. Car trunk is much less important than design. Car trunk, much less important, so I put the bar in the right. Note that the other relationships are not necessary to input in the software. They are already calculated by the software. So we have to input only these three relationships. For decision maker two, price is much more important than car trunk, much more important. Price is more important than design, more important than design. Car trunk is equivalent to design, so I put the bar in the middle. I let the bar in the middle. Okay? So continue.
Go ahead.
The next step is to establish the performance of the alternative in the light of qualitative criteria. So focus for decision maker one, criterion design, focus is worse than Virtus, so worse. Focus is worse than Corolla, worse than Corolla. Equivalent to Sentra, equivalent to Sentra. Worse than Civic, worse than Civic. Worse than Cerato, worse than Cerato. Virtus. Virtus is worse than Corolla, worse than Corolla. Equivalent to Sentra, so I put the bar in the middle. Virtus is worse than Civic, and worse than Cerato, worse than Cerato. Corolla is better than Sentra, equivalent to Civic, and better than Cerato. So better than Sentra, equivalent to Civic, better than Cerato. Sentra is worse than Civic and Cerato. Sentra was worse. Civic is better than Cerato. Better than Cerato. Okay, in this point, we finished the input of decision maker one and we start decision maker two. So decision maker two, here we have this preference. Focus is better than Virtus, focus is better than Virtus, much worse than Corolla, equivalent to Central, so I put the bar in the middle, worse than Civic and better than Cerato. Worse than Civic, better than Cerato. Virtus, worse than Corolla, equivalent to Central. Worse than Civic, equivalent to Cerato. Worse, equivalent. Corolla, better, equivalent, better. Better, equivalent, better. Centra, worse, worse. Worse, worse. And Civic, better than Cerato. I'll add some seconds. Continue. So the software already calculated the cardinal values of the criterion design. These values of car trunk and price were inputted by us in the start of the process. And here I have to input the Q, P, and V values. In this case, we consider for the criterion price, Q 5, P 10, and V 30. 5, 10, 30. Car trunk 10, 20, 50. 10, 20, 50. Design 0.5, 1, and 2. Note that these values, to obtain these values, we have to consider the distribution of data. So it doesn't make sense establish Q equal to 5 if the maximum value in the criterion is 2, for example. So we have to analyze individually each criterion. Continue. Now we have the final results of the method. We have the final weights of criteria, the scores of alternatives, and classifications in each procedure. So it's interesting to observe that for BH procedure, Cerato, Centra, and Virtus obtained the Class A performance. But considering the BN procedure, only Cerato and Virtus obtained the Class A. It's interesting to merge these results and verify that Cerato and Virtus, in our analysis, obtained the Class A performance and can be considered the most indicated cars, vehicles to be acquired or to be chosen in this research. Another interesting point of the software is a summary of the results. So if we click in download summary, we access this spreadsheet in Excel that brings us the values calculated by the software for BH and BN, BH2, BH1, the calculations that we performed in the slide. Note that price is a cost criterion, so the values are with the sign of minus. The parameters Q, P, V, and W represent the weights of criteria calculated by the software. Concordance, discordance, these concepts were explained in other presentations, and they aren't the focus of the today presentations. Credibility and the results with the final relationships. Not important feature is the possibility to change the curve level to verify the behavior of the alternatives. So if I change to 0.9, for example, the software update the results, and we verify that for BH procedure, in the first analysis, Focus also presented the Class A performance. If I increase,
I can use like a sensibility analysis.
Exato. we can use this change to sensitivity analysis to verify the behavior of objectives in more half scenarios. So now I want to show you some applications of the method. This paper was published in Proceed and Computer Science, a multi-criteria decision-making approach to classify military bases for the Brazilian Navy. In this paper, we applied ELECTRE-MOr method through the software to classify possible headquarters to Brazilian Navy in order to build a second squadron for the Brazilian Navy ships.
I support. The method is very new, but you have so many papers using the method.
Yeah, very interesting. This method is being well accepted by the academic society because it's a hybrid method that provides an ordinal input of weights and provides a cardinal value. So it treats the subjectivity of the decision-making process, making the decision-making process more reliable, more transparent, more robust and sensible. Another application, strategic support for the distribution of vaccines against COVID-19 to Brazilian remote areas, a multi-criteria approach in the light of
I want to use this method with my students at Military Institute of Engineering. It's wonderful.
Perfect, Professor. It will be a pleasure helping them if they have some doubts about the method.
Okay. Oh my God! There's another paper.
Another paper. We have some papers. We have many papers.
Machine paper.
Multicriteria analysis in additive manufacturing.
And with Scopus too.
Yeah, all these papers are indexed in Scopus database.
Oh my goodness.
We have many more papers, I would say, with less relevance. So here I brought only indexed in Scopus and JCR databases. In this paper, we applied the ELECTRE-MOr to classify 3D printers. This paper was published in Brazilian Navy.
My goodness, another one.
Another one. Developing a computational technology for high-level making decision, a contribution of Brazilian Navy to selecting autoclaves in the fight against COVID-19. We applied this method in many
different situations.
Yes,
I can see we can use in many completely different situations.
Yes, it can be used in operational, tactical, strategic spheres. So it's a flexible tool to support the decision-making process, and I think it's the main feature of this methodology, this flexibility. Another application, proposal and application of new multi-criteria hybrid model, ELECTRE-MOr, a contribution with Brazilian Navy in acquisition of speedboats to combat COVID-19.
So many applications.
That brings me to the end of my presentation. I let the references that based our meeting. If you want, send me doubts, recommendations, suggestions, possible partnerships to make or to write papers. I let my email and ResearchGate profile to possible contacts. So
wonderful.
I appreciate this invitation, Professor. Thank you very much. It was a pleasure. It's always a pleasure to talk about operational research and multi-criteria decision making. I hope you can understand how to use and the goal of this method based on this presentation. And I am ready for next meetings. And thank you.
It's wonderful. And I realized that the software is very useful and very easy to use, very friendly. You need to fill out the data, only fill out the data, and the software can calculate everything for us. Very,
Yes.
very simple use, very easy. How many criteria? How many
decision makers? How many alternatives?
You can put the values and okay.
Exactly, Professor. Our objective in the research group is spread these methods that often present some complicated calculations, a great volume or quantity of data to be treated. So without a computational tool, it's hard to use
Exactly.
these methods
I think so.
in real problems.
I think tools like that is very important because mainly when we talk about operational research, sometimes we have so hard methods, and many people doesn't like mathematics or
statistics.
So if you have easy software that you can input the data and the software can calculate the result, it's wonderful. And many people maybe doesn't like tools like that because, oh, you need to know the method. I don't think so. Because, for example, if we can think about a huge example of success, like analytic hierarchy process. Thomas Sachs developed analytic hierarchy process in the late, I think 18, I don't know, maybe 1777, I think. And he developed the method and developed a software, the both. And the method are used all around the world. And we have many others examples like Prometheus, like
ELECTRE.
Yeah, developed by Bernard Roy. And we have another examples. So we think when we have a very difficult mathematical, I'm saying about math. When we have a very difficult method, it's good to develop a software that can calculate the results. I think it is a good idea. If it's simple, we don't need like a mean, like a, it's okay. But I could see this method is a complex method. This isn't a simple method. So if you like a research, if you wish that people use your method, you have to facilitate the use of the method. So I think it is a excellent idea. You know. So Professor, thank you very much for your presentation. It's a pleasure receive you here in Operational Research House. I'm so grateful for your presentation, and if somebody have some question, can send an email or write
ResearchGate profile.
Okay, no
LinkedIn
profile, LinkedIn. Okay, and if you enjoy this video, please subscribe and click on the bell. I think we are helping many people to use the method of operational research. So thank you very much. Bye-bye.
Bye-bye.